Okay, so going on to the last portion of this practice is going to have us make an assembly. I would recommend that you close any of the open parts that you have, save them and close them before you move on to the assembly sections. You don't want to have SOLIDWORKS doing more work than it needs to do. So I'm going to start by downloading the zip file on this. Please be careful that you're unpacking the zip file to some known location. So I'm going to move this from my downloads folder to my desktop, and I actually have a SOLIDWORKS folder on here that I'm going to paste that into. So I've got the ARM base, the counterweight, the slot, and the sling, as well as the previous examples that I went through on this folder. After that, I'll go ahead and start an assembly, but I do want to make sure I'm reading these prompts, especially for the assembly problems. You always want to read the entire question on these exams, because a lot of times there's hints as to what you should be doing or how you're supposed to be making the parts. So open, extract the files to your hard drive, save your assembly in the same folder as the parts, save frequently. It's good advice. When I build the Trebuchet, it has a base, an arm, a sling, a shot, and a counterweight. So it's one of each of the parts. It's in inch, pound, second. We're going to use 2 decimals. The assembly origin is shown in the views below. I do recommend you view these views outside of the test software, or at least you zoom in on them so that way you can see what's going on inside these a little bit better. So I'm going to open this up. I'm told that the base origin is coincident with the assembly origin with the axes aligned. So that's the first part I need to bring in to make sure I have that set up. So I'm going to go into File, New, click Assembly, click OK. I'm going to set my unit system as the first thing I do. It's always a good first step. So I'm already in inch, pound, second, so that's good. I'm going to select the base as the first part. I'll hit Open. And again, to keep the axes aligned, all I need to do is click on the green check mark. You click on the green check mark, the first part will be fixed with its origin aligned with the origin of the assembly. And then if I compare that to my drawing, you can see that the origin is on kind of the middle left side of that part, and X is going kind of to the right when viewing it from the side, and Y is up. So if I reorient this, you'll notice the X is going to the right and Y is going up. If I look at it from the front, I'm gonna move this over a little bit. You can see that I have Y up and Z to the right. So those are the views that I'm given inside this part. So that looks good. I'm going to save this in the same directory as my parts. So I'll do save as. I've got the SOLIDWORKS folder on my desktop. I'm just going to call it part C, or let's call it assembly C. Do save all. It wants to update the components for the correct version. And then I can go back and start saying, okay, what are the next step here? The arm's center hole is concentric with the top bar of the base. So let's bring in the arm. So I'm going to drag in the arm. I'm going to make the center hole of the arm concentric with the bar on the base. So this circle and this circle can be concentric. I just recommend using the faces, because if I use the edges, it's going to be of a stronger constraint. This side of the arm is coincident with the side of the narrow portion of the top bar on the base. The center top plane of the arm should be 8 degrees from the vertical face as shown below. So let's align this in the center first using the sides of these positions. And most of the time when you're doing these, the position of the part should make sense. So if you've got it set up and it works the way kind of it should, then you're on the right track. This angle A, which again, I'll go back to the view so we can zoom in on this a little bit more. It says between the top plane of the arm and the vertical face on the side of the base as shown. So the top plane is going to be this orange part, and then this vertical face is going to be this kind of purple one. So I'm going to go into the reference planes for my arm. So I'm going to hide the base and show the arm. I'm going to find the top plane. So there's the top plane of the arm. And then there's the side plane of the base that I want to use. And I'm going to add a mate. Oops, sorry, wrong button. I'm going to add a mate for those two features. And I'm going to set that as an angle. So put that in there, set it as an angle. and I want that angle to be 135 degrees. Oh, I'm in radians. Why am I in radians? Let's do 135 degrees. I'm not sure how I got into radians in inch/pound/second. It's interesting. I'm going to note that that is not the alignment that I want. So I'm going to try flipping the alignment here. That's still not the one I want. I'm going to undo that flip and then try flipping the other one. And then if that's still not right, I'll go to the flip in both directions. So I want the angle here to be 130, and I want it to match, or sorry, 135, and I want it to match how it's shown inside the view. So that one looks the closest to what I have there. So I'll accept that. And again, if you want to put in a dimension that shows the value A, you can, but that's not going to drive the part. To have it be set at that position, you need to use the mates. So that's the second set on there. So 2 is done. The hole on the sling is concentric with the bar on the end of the long arm. So let's bring in the sling. And then there's the hole here on the end of the sling. So I'll make that concentric with the end of the bar. And then probably the next thing here is just going to align this in the middle. So I'm just go ahead and try it and see if it looks like it's right. That looks good. So it's no gap there. On a lot of the assemblies inside these
Dr.
practices
Lewin,
don't
could you
have a
go
gap.
back to the arm mate with the
The angle?
base, please?
Yeah.
Yes, please.
So let me close this one. And again, in my mates, I can see all the mates that I have here. So I'm just going to delete the angle mate. And so now this can rotate back in line. And I can do this with the mate tool open first or afterwards. If you need to select the top plane inside the arm, because that's the only plane that's going to be parallel. There's no other surfaces that are parallel with that plane in the part. So make sure you're selecting the top plane from the features inside the model tree here. And then the other thing I'm going to select is just the side or really any vertical plane on my base. Once I have those two selected, then I can toggle this to angles, and then I can type in the value. This gives it at 135, and I use the units of degrees. And it converted that to radians because somehow I managed to toggle my units to radians for some reason. Now with that angle that I want right there, it's not really the position. 35 degrees. There you go. So I do want to edit that angle so that way the alignment matches what I want. So in this case, I'm flipping the dimension and also the alignment so that's going in the right kind of orientation.
How do you know when to flip the alignment and not just the dimension?
That's a good question. It's based off the faces that you're selecting. You don't really know which combination is going to be best just by looking at it. At least I don't usually know just by looking at it. I will toggle them until I get the alignment that I want. And it should match what you're given in the drawing reasonably well. I can
Okay,
exit
thank
the
you.
mate tool and then kind of show the value on the dimension. And you can see that right now it's actually doing this angle between kind of the line here and the line here. And that's going to be equivalent to the angle on the opposite side of those two faces. So I'm okay with that. I can also go into my
Thank you.
unit system and edit it. So I'm using degrees instead of radians. I don't know why it's using radians, honestly. It should default to degrees. And again, we can see this.
I have a quick question.
Yeah, go ahead.
Would you be able to set the angle as a global variable in an assembly?
Yeah, so if you want to, you can go into tools and I can set equations. I can say this is equal to A
Mhm.
and then set that equal to 125 degrees. And then when I define my angle in the mate,
Okay, you could just type A.
well, you want to say equal to A.
Oh, equals A. Okay, got
And
it.
then I can just use A. like that, and it's gonna replace
Okay.
it. You can also do it after you've made the angle. If you just double click on the dimension, then you can say equal to global variables A.
Okay. Thank you.
So you can change it either way. And if you expected you wanted to change A, like so in the next part it's going to say A to some other value, then that would make sense.
Okay, got it.
And probably it's a good idea to look at the next question, see what it's going to have you do, so you're watching out for that. Yeah. All right, getting back on to the kind of the steps here. The spherical end of the sling should be tangent with the top of the base of the platform so that it lies. Oh, that's not what I wanted. So it lies concentric with the surface of the shot. Oh, and is concentric with the surface of the shot. So let's see the first part of that. I'll go back into the mate tool. I'll put this outer surface of the sling tangentially aligned on the top of the part. So it's kind of intuiting what I want there. And then I need to add the shot. So I'm going to bring in the part for the shot. I gotta exit the mate tool first. And then I make that concentric with this cylindrical face as well. Got that. And let's see here, the hole and the counterweight is concentric with the bar on the short end of the arm. So let's bring in the counterweight. Counterweight. And then I'll make this hole here concentric with the bar on the end. And again, I'm going to assume just like last time that this goes in the middle. Most of the time with these, you can kind of assume that those alignments are appropriate. And it says that the right plane of the counterweight should remain vertical, parallel with the right plane of the assembly. So just like last time, we'll go to the right plane of the assembly and the right plane of the counterweight, and I'll just set those two as parallel and click OK. So you can see all the mates that I have here gone through. I can see that the only thing that's underdefined is the shot. If I try and move that around, it should only rotate inside the position, and so it's not going to change the center of mass regardless of what that rotation is. So I've got everything fully defined with that. I've gone through all the parts of the descriptions. It wants to know what the Y position of the center of mass of the assembly is. Again, going to evaluate, I'm going to do mass properties. And I have here the center of mass location. I have 3.31, which matches this option here. One thing that you got to watch out for, if you have a part selected and then new mass properties, it's going to give you the properties of that part and not the whole assembly. So make sure you don't have anything selected before you click on the mass properties so that you're getting the assembly mass properties. Click that one, go to the next part. And here it just wants me to change. So now I have a new A, which kind of gets back to Gator's question. But if I've had that set as global variable, it's easy for me to change it. I've got A and a B. I need to remove the tangent constraint between the end of the sling and the top of the base, and then add a new one for the angle. So I'm going to remove the tangent constraint. I'll find that one right here. I can delete it or suppress it. I'm just going to suppress it in case I want to bring it back in later. And then I need to change the angle. So I can go into my equations and then change A to 10 degrees. Oh, not 110, just 10. I could also go into the angle mate and then just manually change this. But if you're using global variables, then stick with them. Probably also important to note that you want to check and make sure you're looking at this from the correct view with X going to the right and not this view here with X going to the left, because it's pretty easy to get that flipped. So make sure you're looking at it from the right view if you have parts that are symmetric. I'm going to position that kind of close to where I want it, and then I'm going to try and define the angle B. It just says adds the constraint for the angle B and gives me the view. It doesn't say what planes I'm supposed to use. I'm going to assume that since this is highlighted and it's the same angle as used for A, that's going to use the top plane of the arm. So I'm going to go back into the arm. I'm going to get the top plane there. There may be a plane inside the sling that I can use, but it seems like this face is reasonably well aligned with the line that I'm given. So I'm going to click that as well. And then I'm going to go into my assembly options and add a mate, set it as an angle. and then give it a value of 6 degrees. And again, that did mess up my side, so I'm just gonna play with my flips here. And I wanna get whichever one gives me the appropriate size kind of position that I want. That one looks good. I'll exit the mate tool. I wanna see that angle on the drawing. I'm gonna kind of drag it out. And you can see where the endpoints of this are kind of pointing through. And so that does look like what I have in the drawing. Looks like the one I have in mind is probably a smaller angle B than what was used to make this one, but that is kind of reasonable. If you want to temporarily make that bigger, just so you can kind of see what it looks like with a different angle and confirm that, okay, that makes sense, then that's not a bad idea. Just make sure you change it back to what you were given inside your specific quiz before you evaluate and submit your answers. So here I've got A10, B6. I can confirm those values on my part. Just one last time. So there's the 6. There's the 10. Move that so you can see it. That looks good. And it wants to know the new center of mass of the assembly in the Y direction. So same as last time, more or less. Come back into my evaluate mass properties. Get my center of mass in the Y direction. Here we have 1.71. And mostly the difference there is because the counterweight has moved down, right? So the counterweight is heavy and it's moved from a high position to a low position. And I can submit, and hopefully we'll get a correct answer on all these. We got 8. I missed one. What did we miss? I probably copied and pasted the values for this second revision incorrectly. Let's go back to our part and we can check and see what I did wrong. So let me close this. I'll save all. And then I'm going to open up the step 2. So in step 2, part B, if I roll back to before I had these last few revisions, should be there, and set my A and my B to 1.25. And again, I changed these for part C and 2.75. And evaluate my mass properties. Oh, it's just down here. I'm getting 2 point. That's not the same as what I put in there anyways. Let's look at. Oh, I'm missing the cut extrude. There we go. Now let's evaluate. So 2.35. It should have been 2.35. I probably just copied and pasted wrong. Or I copied it for part the first part and then didn't copy again, didn't press C or control or something. So that's right, it's just wrong on here. If this was the SOLIDWORKS certification exam, I would get that wrong. So there's no kind of opportunity to check your answers. But if you do get one of them wrong, do go back and check and see kind of why you got it wrong. See if you can resolve that. All right, I'm gonna stop recording.